Today we're going to investigate the volume of cones and spheres, and we'll start off by looking at the volume of cones. Cones are very similar to cylinders, except that cones only have one circular base. At the other end of the base is the vertex point, which again we call the apex. Recall the volume formula for a cylinder. If we wanted to calculate the volume of a cylinder, we would use the formula V equals pi r squared times h. All right, we would square the radius of the cylinder, multiply it by the height, and multiply it by pi as well. The volume formula for a cone is very similar. Okay, now in class, we're going to watch a short video to see how the two formulas are related to each other. Okay, but the short definition here for the volume formula for a cone is that if the cone has the same radius and the same height as the cylinder, then if I were to fill up the cone and pour it into the cylinder, I would need to do that 3 times in order to fill up the cylinder. Okay, so this means if we fill this in from watching the video, the cone fills the cylinder 3 times. Therefore, the volume formula for a cone is blank. Well, we're going to take the volume formula of the cylinder, which is pi r squared times h. But since it took 3 times for us to fill up the cylinder using the cone, the volume of the cone is only going to be a third of pi r squared times h. All right, and this is the volume formula that we will use for any cone where we're trying to find the volume. So let's try that here in our first example. It says to find the volume of the cone, round your answer to the nearest hundredth. So we'll start by writing our volume formula. V equals 1/3 pi r squared times the height. Looking at our cylinder, we're going to have 1/3 times pi times the radius right here is 1.5 inches. We're going to square that number. And we're going to multiply by the height, which we can see right here is 4 inches. Following order of operations, we're going to do the exponent first. So we're going to have 1/3 times pi. And then 1.5 times itself is going to be 2 and 25 hundredths. And then the height is still 4. Okay, I'm going to multiply 2 and 25 hundredths by 4. So I'm going to keep the 1/3 pi times, if you multiply 2 and 25 hundredths by 4, you get 9. And so now I have a third of pi times 9. Well, if I find 1/3 of 9, well, that leaves me with 3. So I end up with a volume of 3 pi. But they wanted me to round to the nearest hundredth, so I'm actually going to do the multiplication. And if you were to multiply 3 by pi, all right, you're going to end up with 9 and 424777961, and the units are cubic inches. And now we'll take this number and round it to the nearest hundredth. It looks like 42 hundredths. That 4 is not enough to round this up. So we're going to say that the volume is approximately 9 and 42 hundredths cubic inches. In example 2, it says that Kiara is filling a cone-shaped pastry bag with frosting from a cylinder-shaped container. How much frosting can the pastry bag hold? How many times can Kiara fill the pastry bag? Okay, so let's start with the pastry bag, and it's in the shape of a cone. So I'm going to write a cone here, and I'm going to use the volume formula because we are filling the pastry bag. Volume equals 1/3 of pi r squared times the height. And we're going to have 1/3 times pi. Now, the radius right here, I can see the diameter is 4 inches, which means the radius would be half of that, or 2 inches. So 2 squared times the height, which is going to be 5 inches. Volume equals 1/3 pi times 2 squared is 4 times 5. And now 1/3 pi times 20. Okay, so I'm going to have 20 thirds pi. All right, 1/3 times 20 is 20 thirds pi. And now I'm going to leave this in terms of pi for just a moment. This is going to be cubic inches. And now I'm going to move on to the cylinder, which is the frosting container. It's in the shape of a cylinder. And the volume formula, V equals pi r squared times the height. Well, notice here that the dimensions of the cylinder and the cone are the same. It has a diameter of 4, it has a height of 5. So I'm just going to substitute in the same values. I'm just not going to have that 1/3. So I'm going to have pi times 2 squared times 5, which becomes pi times 4 times 5, and pi times 20. 4 times 5 is 20, so we're going to have 20 pi cubic inches. Okay, so the reason why I left it like this in terms of pi for each example is because this is going to help answer this second question. How many times can Kiara fill the pastry bag? Okay, well, if the volume of the cylinder is 20 pi cubic inches, and the volume of the cone is 20/3 pi cubic inches, that means that I would be able to fill this pastry-shaped bag 3 times. And that matches what we said earlier up above. Okay, if we have a cone and a cylinder with the same radius and the same height, the cone fills the cylinder 3 times. Or excuse me, yeah, the cone fills the cylinder 3 times. So we can answer this first question, all right? Kiara can fill the bag 3 times. All right, that answers the second question. The first question said, how much frosting can the pastry bag hold? So how much frosting can I get in here? Well, the volume of the cone is 20/3 pi cubic inches. Now, that number doesn't, it's kind of a weird thing to say, I can fill it with 20/3 pi cubic inches. So let's actually figure out what that's going to be. Okay, so in my calculator here, I'm going to do 20 divided by 3, and then times pi. And there is my number. So I'm going to have 20 and 94395,102. Okay, and so now I'll round this to the nearest cubic inch. All right, that 9 is going to bump us up to about 21 cubic inches. So I can say that the bag holds about 21 cubic inches of frosting. Okay, that would be the volume of the bag, which is in the shape of a cone. In example 3, we're told that the circumference of the base of a cone is 6 pi inches. What is the volume of the cone in terms of pi? So looking at this cone right now, I can see that it has a height of 13 inches. The radius I don't know. And if you recall the volume formula for a cone, V equals 1/3 pi r squared h, we need to know the value of the radius before we can calculate the volume. Since they told me that the circumference of the circular base is 6 pi inches, I can figure out the radius by using the circumference formula. So recall that circumference equals 2 pi r, and the circumference is 6 pi, so I'll replace c with 6 pi. 6 pi equals 2 pi r. And now I can easily calculate the value of the radius. I'll start by dividing by pi. All right, pi divided by itself is 1, so 6 equals 2r. And now if you divide by 2, then the radius must be equal to 3. So this right here is 3 inches. Now I can figure out the volume. Again, 1/3 pi r squared times the height. And we'll have 1/3 pi times the radius. We just calculated to be 3, so that'll be squared. And then the height is 13. Doing the exponent first, 3 squared is 9. And now I'm going to do 1/3 of 9. 3 goes into 9 3 times. So V equals pi times 3 times 13. And now they asked me for the volume of the cone in terms of pi, so I'm just going to do 3 times 13, which equals 39. So the volume of this cone is going to be 39 pi, and the units are cubic inches. In the next part of the lesson, we're going to be looking for the volume of spheres. A sphere is a surface consisting of all the points that are an equal distance from a center point. A segment drawn from the center point to any point on the sphere is known as its radius. A sphere is essentially a three-dimensional version of a circle. Not surprisingly, the volume formula of a sphere depends upon its radius and pi. The volume formula for any sphere, V equals 4/3 pi r cubed, so to the third power. We're going to use that formula to find the volume of spheres with the given radii. We'll round our answers to the nearest whole unit. So in question A, we're going to start with a sphere that has a radius of 12 feet. We'll start by writing down the volume formula. V equals 4/3 pi r cubed. And now we'll substitute in the value of the radius. So we're going to have 4/3 pi times 12 cubed. And now with the order of operations, we'll do the exponent first. So we're going to have 4/3 pi times 12 times 12 is 144. 144 times 12 is 1,728. Okay, now 1,728 is divisible by 3, so I'm going to simplify here, all right? 3 goes into 1,728 576 times. Okay, so I'm going to have 4 times pi times 576. So I'll start by doing 4 times 576, and that's going to be 2,304 times pi. So this would be the volume in terms of pi. That would be cubic feet for the units. But they wanted us to round to the nearest whole unit, so we're actually going to do that multiplication. 2,304 times pi. And that's going to give you 7,238 and 229,474. And they said round to the nearest whole unit. Okay, that 2 in the 10th place is not enough to bump us up. So our volume is going to be approximately 7,238 cubic feet. What if we had a radius of 3 centimeters? What would be the volume of the sphere this time? So same process, start with the formula. V equals 4/3 pi r cubed. And then just substitute in the value of the radius, which in this case is 3. Order of operations again, do the exponent first. 3 cubed, 3 times 3 is 9, times 3 is 27. And again, 27 is divisible by 3, so I'll simplify. 3 goes into 27 9 times. So I have 4 times pi times 9. 4 times 9 is 36. So I would have 36 pi cubic centimeters. But again, they said round to the nearest unit, so I'll actually do that multiplication. And if you do 36 times pi, you're going to end up with 113 and 0.973355. Okay, that 0 in the 10th place is not enough to round us up. So the volume of this sphere would be approximately 113 cubic centimeters. In example 2, we're told that a corn silo is an example of a composite figure in the shape of a cylinder with a hemisphere of the same diameter on top. The diameter of this silo is 4 meters. How many cubic meters of corn can be stored in the silo? Round your answer to the nearest tenth. Okay, so again, we have a composite figure, we have a cylinder, and then we have a hemisphere on top. A hemisphere is a half of a sphere. Okay, so we're filling up this silo, which means that we're going to be dealing with volume. Why don't we start with the cylinder first? Okay, for the cylinder. To find the volume of a cylinder, remember that you use the formula pi r squared times h. Okay, so I'm going to have pi times the radius squared. Well, the radius that they told us about, well, the diameter is 4 meters. So that means that the radius would be half of that, or 2 meters. So we're going to have 2 squared times the height of the cylinder right here is 10 meters. So now if I follow order of operations and square 2, I get 4. So pi times 4 times 10. And then V equals 10 times 4 is 40. 40 pi cubic meters is the volume of the cylinder. And I'm just going to keep this in terms of pi for right now. And now I have to find the volume of the hemisphere. Okay, well, the volume formula for a sphere, remember, is 4/3 pi r cubed. But a hemisphere is a half of a cube, or excuse me, a half of a sphere rather. So I'm going to do a half of this, which means I can actually simplify these fractions in the beginning. 2 goes into 4 twice. So really my volume formula for a cylinder, for a hemisphere rather, is going to be 2/3 pi r cubed. Substituting in for the radius, we said that the diameter was 4, so the radius had to be 2. And if we do 2 to the third power, so we're going to have 2/3 times pi times 2 times 2 is 4, times 2 again is 8. And now, well, 3 doesn't simplify with the 8, so I'm just going to multiply here. 2/3 times 8 over 1 is going to be 16/3 pi. And again, it's cubic meters for the units. So that's for the volume of the hemisphere. Now to get the total volume, okay, well, I'm going to have to add these two together. So I'm going to take the volume of the hemisphere, which was 16/3 pi, and I'm going to add to that the volume of the cylinder, which was 40 pi. But I'm going to have to get a common denominator over here. So I'm going to have something over 3. Well, 40 over 1 equals 120 over 3. So this is going to be 120/3 times pi. 16/3 pi plus 120/3 pi is 136/3 pi. And now if I actually do that on my calculator here, okay, I'm going to have 136 divided by 3, and then times pi, and there is my decimal, all right, 142 and 418,867. And now it said to round your answer to the nearest tenth. So I'm going to say that the volume is approximately, well, that one's not going to bump us up. So we're going to have 142 and 4/10 cubic meters as the volume of the silo. In example 3, we're told that a tent has the shape of a hemisphere shown below with a base diameter of 10 feet. Question A asks, what is the height of the tallest person that can stand upright in the tent? Okay, so looking at this hemisphere here, we can see that it has a diameter of 10 feet. So from here to here is 10 feet. So if I think about my center point here, all right, if the diameter is 10 feet, then the radius here must be 5 feet. And remember that the radius of a sphere or a hemisphere starts at the center point and goes to any point on the sphere. Okay, so this is 5 feet, and this is 5 feet, and even going straight up to the very top there, perpendicularly, that also is going to be 5 feet. So if the diameter equals 10 feet, well, then 10 divided by 2 equals 5 for the radius. That means that the tallest person can be 5 feet tall. Okay, that's the tallest person that would be able to stand upright. Anyone that's over 5 feet tall is going to have to bend over so that they can fit in that tent. Okay, question B says, to the nearest square foot, how much floor area does the tent have? So we're only looking at the floor of the tent. So we're looking at this base here, which we know is a circle. And they want to know the area for that circle. Recall the area formula of a circle. Area equals pi r squared. And then we're going to substitute in the value of the radius, which we set up here was 5. A equals pi times 5 squared. 5 squared is 25 times pi. And then if we multiply 25 by pi, that's going to give us the decimal 78 and 53981634. And they said to round this to the nearest square foot. So this is approximately, well, that's 78, but that 5 in the tenths place will round us up to about 79. Okay, so the area of the floor is about 79 square feet. Okay. Finally, in question C, it says to the nearest cubic foot, how much volume does the tent have? So we're going to use the volume formula for a hemisphere, which we recall back in our last question with the corn silo for the hemisphere, we used the formula V equals 2/3 pi r cubed. Since the hemisphere is half of a sphere, V equals 2/3 pi r cubed. And now we'll fill in with the value of the radius, which we calculated earlier to be 5. If we cube 5, all right, 2/3 pi times 5 times 5 is 25. 25 times 5 is 125. Okay, 3 doesn't go into 125, so I'm just going to multiply 2/3 by 125 over 1, which is going to equal 250 over 3, and then times pi. So now since they want us to round, I'm going to actually calculate this. 250 divided by 3, and then times pi. And there is my decimal. Let's write that down. 2V equals 261 and 7993878. Okay, and then they said they wanted to the nearest cubic foot. V is approximately, well, that 7 is enough to bump us up to 262. So the volume of the tent is about 262, and the units again are cubic feet.